Okay, number one, we're going to do f plus g of x. So that's where we just add the like terms. So we've got x squared plus 4 is our f of x. Our g of x is 7 minus x. So when we combine like terms, we get x squared minus x plus 11. For f minus g of x, well, of x squared plus 4 minus 7 minus x. I would recommend taking that subtraction and distributing it to make it a negative 7 and a positive x. Now you can add like terms. X squared plus x, that is a negative 7, didn't fit in there real well, but 4 and negative 7 together make negative 3. Maybe I'll come over here for the multiplication and division. So x squared plus 4 being multiplied by 7 minus x, that becomes a FOIL problem. 7x squared minus x cubed plus 28 minus 4x. We combine like terms, get negative x cubed plus 7x squared minus 4x plus 28. And then, lastly, is division. X squared plus 4 over 7 minus x. There's nothing to simplify there. I could rearrange that denominator and call it negative x plus 7 because we typically write it in the other order. And then I guess you could take the negative out and even distribute it to the numerator. I'm not going to bother with that right now for sake of time, but you could certainly do that. The domain restriction here is that x cannot equal 7 because that would give us a denominator of 0. Now we're going to do composition. So g of h of x first. So it's g of negative 2x squared. So that would be negative 2x squared plus 8. There's no like terms. As for the domain and the range, domain, it's going to be a parabola, so it's all real numbers for the domain. The range, that will be restricted. It is a parabola that's opening down, so it'd be nice to know where its vertex is. So if I did negative b over 2a, the b is 0. Negative 0 over 2a, it's going to be a 0, so 0 plug 0 in, and we get 8, so 0, 8 is the vertex. It is opening down, so y will be less than or equal to, since it's opening down, the 8. And then for h of g of x, so g of x is x plus 8. I'm plugging that in to the h, so negative 2 times x plus 8 squared. When you square x plus 8, you have to actually think of it as x plus 8 times x plus 8 and FOIL it out. So I'll end up with x squared. I'll get an 8x and another 8x. Together that makes 16x, and then I'll get 64. And then I've got to distribute the negative 2 throughout. So negative 2x squared minus 32x minus 128. That is a parabola, so its domain is all reals. Its range, we'll have to do the negative b over 2a, and this one is not going to be quite as easy as the previous one. So off to the side, I'm going to do negative 32, that's positive 32, over 2 times negative 2 is negative 4, so I get a negative 8. Then I'll have to plug negative 8 in. I'm just going to do that on the calculator real quick. So I've got negative 2 times negative 8 squared minus 32 times negative 8 minus 128. We get 0. This is opening downward, so it's less than or equal to the 0. Okay, now find the inverse. That's where we switch around the x and the y. Subtract the 7. Divide by negative 5, I'm going to get negative 1/5 x plus 7/5. can change it back into function notation, the inverse notation. So there's the function. Now I'm supposed to graph the original and the inverse. So there's the original. 7, that's 1 and 1.4, about there. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, and so they are a reflection across the line y equals x. Next one. Got a square root, so y equals, and it's positive negative because I'm square rooting. X plus 4, so I change it back into function notation. And so then, to graph the original, it's a parabola. Negative b over 2a, we get a 0. Plug it in, negative 4, and then I'm going to surround 0, 1, 2, negative 1, negative 2. I'm going to plug in 1. 1 squared minus 4 is negative 3. Plug in 2. 2 squared minus 4 is 0. So negative 2, 0. Negative 1, negative 3. 0, negative 4. 1, negative 3. 2, 0. So there's f of x. And now for these, I actually have 2 of them. I have a positive absolute value, or square root of x plus 4, and then a negative square root of x plus 4. They each have their own table of values. The smallest number I can plug in is negative 4, so I'll plug in negative 4, negative 3, and 0. Plug in negative 4, I get 0, and I'll get 1, and then I'll get 2 over here. I'll plug in the same numbers. When I plug in negative 4, the square root is 0, and then it's negative, so that's still a 0. Plug in negative 3, I get 1. Square root of 1 is 1. Make it negative because there's a negative in front, and then I'll end up with a negative 2 also. Negative 4, 0. Negative 3, 1. 0, 2. And then when I graph the other one, I see that together, when I combine the two of them together, I'll get this sideways parabola. Okay, and then next one, plus y plus 1, subtract the 1, multiply by 4, so 4x minus 4, put it back in function notation. The original. Important observation to make. Every point of the original. For example, this is 0, 1. If you switch, because an inverse is just switching x and y around, if you switch 0 and 1 around, you get 1, 0. Notice that point is on the other one. Similarly, here's negative 4, 0. If we switch those around, it would be 0, negative 4. Look, that's the corresponding point on the other one. And then this one over here was 1, 2, 3, 4, 2. So if I switch those around, I should have 2, 4, and conveniently, it's the matching point of the other one. So if you ever have a graph, you can flip x and y values around to get the other order pair as well. Okay, so we have to do f of g of x and g of f of x. So f of 5x minus 3. So 5x minus 3 plus 3 all over 5. In the numerator, we end up with just 5x. That's over 5, which equals just x. So check, that one worked. Now try the other way around. So 5 times this fraction. Multiplied by 5, the 5's will cancel here, so we'll just get x plus 3 minus 3. That, of course, equals x. There, I verified that one worked. Okay, now 7. Distribute the 4. X plus 4 minus 8 equals x minus 4. This one's not going to work. I'm not even going to bother trying the other one. They are not inverses. It did not equal x. Okay. So the next one I can plug in -3, -2, and 1. So 0, 2 times 0 is 0, so I get -1. Plug in -2. Square root of 1 is 1. Times 2 is 2. Minus 1 is 1. 1 plus 3 is 4. Square root of that is 2. Times 2 is 4. Minus 1 is 3. -3, -1. -2, 1. 1, 3. This first point is an endpoint. Don't pass through it. Just beginning of the whole thing. So the domain, x could be anything greater than or equal to the -3. That was the first point we could plug in. So the range is opening up, so it's greater than or equal to the lowest point it ever was -1. Number 9, we have an inequality. I can plug in 1, 2, and 5. I get -4, -3, -2. So 1, -4, 2, -3, and then 5, -2. Okay, this one is an inequality. Notice there's no equal, so I'm going to do a dashed line. And then after shade, it says to go below, so go below your graph to give your shading. Okay, write each expression in radical form. All right, so I think they want us to write in the other form, because there's nothing I can do with an exponent of 1/6, but they wanted me to write this as the 6th root of 3. Yeah, I won't be able to simplify this, but I can write it in the other form. 15 to the 3/4. This one, I would go ahead and multiply these exponents together first. So 3 times 3/5, that's like 3 over 1 times 3/5. This 3 only goes to the numerator, so it's 9/5. And so then if I write it in the other form, 5th root of c to the 9th. And then on the back page, 3rd root of 27, that's 3. This one, think about the denominator first. That's the square root of 16, and then the whole thing is to the 3rd power. Square root of 16 is 4, so it's 4 to the 3rd, which is 64. 4/9 to the 3/2. Look at the denominator is 2, so it's like a square root of 4/9. And the whole thing is to the 3rd power. Square root of 4/9, that's 2/3. Let's take the whole thing to the 3rd power. 2 to the 3rd is 8. 3 to the 3rd is 27, so 8 over 27. Square root of 64 is 8. And then in the 6, we'll be able to pull that out 3 times. For w, we will pull w out 2 times. Now I do need absolute value around the n, because it was a square root, so it's even. 6 is even. We end up with 3, which is odd. So we do need to throw in an absolute value around the n to the 3rd. 3rd of -8 is -2. And then for a, 9 divided by 3 is 3, no remainder, so just -2 a to the to the 3rd. Because it was a cube root, it was okay to have a negative. 4th root of 48. Well, 48 is not a perfect 4th root, but we can break it into 3 times 16. And the 4th root of 16 is 2. So I would get to pull a 2 out. And then this 3 is going to be stuck inside the 4th root. Now v, be to the 8th divided by 4, so I get to pull out v squared, no v left over. Z 13 divided by 4. Well, like 12 divided by 4 is 3, so I can pull out z 3 times. It accounts for 12 of them. There was a z left. Okay. This kind of looks like a 34, but that was a fourth root. So 2v squared z to the third times the fourth root of 3z. 45, 9 times 5, square root of 9 is 3. I'll also get to pull out an x. I'm going to pull out y 4 times. What am I left with? Well, the 5 and x. So 3x, y to the fourth, square root of 5x. Fourth root, look at that denominator. Right now it has 9, which is 3 squared. I want to get rid of the root, so I need to bring in 2 more 3's. And then it has 3 a's, so I need to bring in 1 more a. So I'm really multiplying by the fourth root of 9a. In the numerator, that's 72a. That kind of looks like 729. Let me rewrite that. I can kind of break my fraction apart anyway. So that's my numerator. Okay, now for my denominator. 9 times 9, that was 81, but the fourth root of that is 3. I get to pull a 3 out, and then I have now a to the fourth, so I get to pull an a out. So here's my answer. Number 21, 3 times negative 4 is negative 12. And then we're going to have 15 times 45, that's 2, so 675, I believe. And so then I can pull, 45 is 15 times 3. So there was a 15 here and a 15 there. So I know I'll be able to pull out a 15, which is 225. So pull a 15 out times the negative 12, that's negative 180. And I'm left then with just 3. So negative square root of 180 times 3. 48, that's 16 times 3. Square root of 16 is 4, so 4 times 8 is 32. I get to pull that out with a 3 left inside. With 75, that's 3 times 25. Square root of 25 is 5. 5 times 6 is 30. Square root is 3. 80, that's a 16 times a 5. Square root of 16 is 4. 4 times 7 is 28. Square root of 5. I do have square roots of 3 I can combine together. 32 minus 30 is 2 of them. 2 square roots of 3 plus 28 square roots of 5. Here I've got a FOIL. Square root of 5 times square root of 5 is 5. Square root of 5 times square root of 2 is square root of 10. Minus square root of 30. Minus the square root of 12. There's no like terms that I can combine. Guess I can simplify the square root of 12 there. For sake of time, I'm not going to do it though, because I know I'm running short on time here. I'm going to multiply by square root of 5 plus 2. Conjugate. In the numerator, we get square root of 15 plus 2 square root of 3. In the denominator, square root of 5 times square root of 5 is 5. We'll get plus 2 square roots of 5 minus 2 square roots of 5 minus 2 times 2 is 4. So 2 square roots of 5 will cancel. So my numerator was square root of 15 plus 2 square roots of 3. And my denominator, I now have 5 minus 4, which is 1. So I don't even need my denominator. Conjugate on this one. 2 plus square root of 2. Six plus 3 square roots of 2 plus 2 square roots of 2 plus 2. 4 plus 2 square roots of 2 minus 2 square roots of 2 minus 2. In the numerator, 6 plus 2 is 8. And you can combine the square roots of 2 to get 5 square roots of 2. The denominator, 2 square roots of 2 cancel. 4 minus 2 is 2. There's my answer. This one I have to add exponents. 1/5 plus 1/2. 1/2 is really, I guess I need to make common denominator of 10 even. Change them both, so 2/10. Oops, plus 5/10. 5/10 to 2/10 add to 7/10. Here we've got to subtract our exponents. 1/2 minus 1/4 is 1/4. Here on the bottom, I'm going to combine these two on the bottom together, 1/6, and then this would be 3/6, that's a 4/6. And now I'll go ahead and subtract 1/3 minus 4/6. Well, that's 2/6. 2/6 minus 4/6 is negative 2/6. So now that's got to go to the denominator. 2/6, of course, can also simplify to 1/3. Better yet. And so now I've got to multiply by n to the 2/3. To fix that, so n to the 2/3 over n. Twelfth root of 64. Well, 64 is 2 to the, let's see, what, I believe 2 to the 6th power. So I can think of this as 12th root of 2 to the 6th. So 6/12ths can simplify. 6/12ths goes to 1/2. So I could write that as 2 to the 1/2. Or actually, I probably should do it this way to be consistent with the form. I should write it as a square root of 2. So the better answer is square root of 2. Three, 4th root's of 36, but that 36 is 6 squared. 4th root of square, that can simplify to 1/2, so that's just a square root of 6. So 3 squared is 6. We've got to solve. Subtract my 6 and cube. X minus 4 equals 27. So x equals 31. Add 1. Square. Add my 5. 14/8. We'll go to 7/4. Subtract my 2. And I'm going to cube everything. 6x minus 5 equals negative 125. Add my 5. Divide by 6. Oh, shoot. I did not realize. I apologize. I've done a lot of these problems apparently that you couldn't even see. I feel really bad for that. I'm about out of time, so I can't redo it, but you can at least see them, I guess, now. That makes for a great video. I apologize. That's what happens when I'm in a hurry. Okay, I'm going to square both sides. 2x minus 5, x minus 1. So I got rid of both square roots at the same time, which is nice. Subtract x, add 5. I got 4. I better check my answer. 8 minus 5 is 3. That's b squared of 3. 4 minus 3 square root of 3 equals square root of 3. That would work, so there's no extraneous solution there. Down here, I'm going to think about that domain restriction. That has to be greater than or equal to 0, so z has to be greater than or equal to negative 5. Okay, so let's go ahead and solve. We'll subtract 4. Square both sides. So z plus 5 has to be greater than or equal to 81. So z has to be less than or equal, I think I said greater than or equal to, I meant less than or equal to 76. So z is less than or equal to 76. We also said it had to be greater than or equal to negative 5. So there's a little bit of an issue there. So we have to be in between. So negative 5 is less than or equal to z is less than or equal to 76. This one, this domain restriction, c plus 4 has to be greater than or equal to 0, so c has to be greater than or equal to negative 4. Excuse me, I'm going to go ahead and subtract the 9. Divide by negative 1. That switches my inequality sign. Now I can square. Subtract 4. C has to be greater than or equal to 5. We also said it has to be greater than or equal to negative 4. Well, if it's greater than or equal to 5, it has to be greater than or equal to negative 4. So I don't really have to include that piece of it. This is a sufficient answer then. And that's the end. Thanks for watching.